Tēnā koutou katoa, no Aotearoa o Whanganui Atara aho. Ko aho te product architect ki RedShield. Ko aho OWASP o Whanganui Atara. Ko Kirk toko ingoa. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Hi. Welcome everyone to the first session of the conference. My name is Kirk Jackson. I'm product architect at RedShield. I also help organize the OWASP Wellington chapter. And it's my pleasure to be here today to talk to you about the OWASP Top 10. I hope you all have a great couple of days. John and the team have put on a really cool conference. The OWASP Top 10 is kind of the reason why OWASP is here. And I thought I would start the day with an introduction. Luckily, we got to double the talk size because when I did a practice run at the Meetup, my talk was twice as long as it should be. First off, let's thank all our lovely sponsors. Without them, the conference wouldn't be as fancy. Yeah, my clicker's dead. Oh well, I'll stand here. So first off, what is OWASP? So John's mostly covered this. It's a website and a bunch of tools and a community that you are all part of. The website is revamped, so hopefully you can find things better. And they have project spotlights, and OWASP Top 10 is frequently the spotlight project. So what is the Top 10? Well, it's a collection of sort of the top 10 most highest severity critical security risks to web applications. It's updated every couple of years. The first version was, man, there's a squeak right where I'm shuffling. Can you hear that? No? Okay, good, only me. So it's updated every couple of years. And the last few updates, I've been doing a more scientific approach to updating it, and the top 10 issues now focus on the root cause problems rather than a symptom. So when you're looking at the top 10 now, hopefully you can see the things that you need to address. So the good thing about the top 10 is it's a good first step to use to understand some of the more prevalent security issues in your web applications and to sort of get guidance. But it's only the first step. Unfortunately, hackers know more than 10 tricks. So it's really a part of your journey. If you're interested in the mechanics of how they chose this top 10, Brian Glass, who's also speaking tomorrow on SAM, has a YouTube talk where he's part of the team that helped produce the top 10. And it's really interesting. They've got statistics. I think there was couple of 100,000 web apps that they included in the survey of common vulnerabilities, and it's a really good talk to get into the nitty-gritty. But what I'm going to focus on is actually what the top 10 are and what the vulnerabilities are, and do a few demos of ones that are easy to demo. I mean, interesting to demo. It's not about what's easy for me. Eek, awkward. Okay, so what are we trying to do? Well, our job as web application developers or application developers is to secure the users. We want to make sure that when they're using our website in their own web browser, that it's secure, the data in their browser is secure, no other sites can access the data, that the traffic between them and the web server is secure, that the web applications itself is secure, I don't know, databases are secure, and I don't know why I've got an arrow pointing at the user, but the user feels secure. So that's kind of our goal, is to just sprinkle security across this whole thing. So we're going to go through the top 10. I won't read them all out now because we're going to go through them. They use kind of like a keyword thing, you know, A01 through to A10. And let's get into it. So broken access control, what is that? Well, that's really about your web server. Man, I hope there's no other people that are colorblind like me because I can't see the red arrow on there. Sorry about that. So that's whether your web server is making good decisions about who can access what. And this came up as one of the most common vulnerabilities in the survey of applications. And, oh, does that help? It does, it helps me. And that some examples are an application that lets people access administrative sections of the site without doing authorization checks, allowing people to elevate to administrative accounts, viewing other people's data, or perhaps even modifying cookies or JWT tokens to change your roles. So let's do a little demo. So I'll introduce you to this demo site that I've been using for a few years because I built it and it's riddled with security issues. What this is, it's an online shop. You can buy things like trips to Barbados and stand-up paddle boards, and it has sort of a registration and a login system on it. So I'll just log in as a regular user. And now I can have a look at my previous orders. So there's one that I prepared earlier for $800, and this is, okay, so it's not a realistic looking order, I just typed in gibberish. Oh, that's not good. That's my credit card number. No one take a photo of this. So there are some issues in this application by design, but if I was able to access other people's orders, maybe I could see their home address and stalk them. Maybe I could intercept their parcels, re-deliver their deliveries to my house, or steal their credit card details. And unfortunately, this application does have an issue. So the screen res means that you can't really see. But the URL on there ends with ID = 7. And I can just change the ID, and now I see Joe Bloggs' order. Oh, man, he's got the same credit card as me. Random. So this is an example of an authorization check not being performed to make sure that I can see only my orders. So pretty simple demo. So what can we do to fix access control issues? Well, there's some guidance on the OWASP site for all of these, and I've just sort of prepared a little summary of them. And actually some talks will go into more depth over the next few days. But here's my sort of 5 guidelines. So make sure that you centralize your access control logic so that if you have issues, you only have one place to modify it, and you can have patterns that all your developers can use. Try not to invent things yourself. If your platform has libraries that you can use, they've probably been well tested, and you'll be able to leverage them. Use a positive security model, so deny access to everything, and then add back the access to just the things the user's allowed to see. As a backstop, make sure that you're logging failures and alerting. And you may consider rate limiting access to things where you can't use other authorization to try and detect abuse if someone's trying lots of different IDs. So that was A1. A2, cryptographic failures. So here we're talking about protecting data. And there's 2 ways our applications use, or 2 things that we have to protect. We have to protect the data going to and from our web server and back to the user, and also protect it when it's at rest, so when it's being stored. So this is a pretty common category of breach. If you're watching the news, I think 1 billion records from a Chinese police department are rumored to have been leaked this week, making it one of the biggest data breaches ever, which is kind of terrifying. And so we need to make sure that we protect data, obviously, everywhere that it is. So common failures here are transferring data without encrypting it. So HTTP rather than HTTPS, or FTP, or sending an email. Not encrypting the storage. So I guess with cloud providers, we can trust them to handle some of this stuff for us if we set the right settings. But we need to make sure that if we have our own physical hard drives in our servers, that someone can't just walk away with the drive and get all the data. So make sure it's encrypted at rest. Using weak cryptos or keys, certificates not being validated, or, gosh darn it, exposing your credit card numbers. So I don't really have a demonstration of this. Hopefully you can picture what happens when you don't encrypt your information. And really the best prevention is to not have the data in the first place. So my sample application shouldn't have credit card numbers in it, and then I don't need to worry about how do I encrypt credit card numbers. Actually, I should be getting a payment processor to do that for me. Make sure you're encrypting at rest in transit, and use strong crypto. So we definitely encourage people not to implement their own cryptographic libraries. Don't try and write AES or think that you can write a better encryption algorithm than the experts. Use an existing library, and also follow the guidance of what libraries to use and which algorithms to use and which not to use, because that does change over time. So injection attacks are fun, and I'd say cross-site scripting is probably the single most common vulnerability in web applications. So let's talk a little bit about what injection attacks are. So injection attacks are when you let the attacker give your application some data, and then you run it as code. So, I guess we were taught at some point that we should keep things separately. We should have the code that we run, and it has its own memory space where it runs, and then we store the data in a different section of memory, and keep those two things separate so that we don't accidentally start running the data. And that's, there's a whole category of overflows and other issues. But when it comes to web applications, we don't follow that advice. We have one big HTTP response that contains content, like my name, structure, like it's inside a paragraph, inside a div, inside this part of the page, content structure, presentation, like what style my name should have, and then code, like some JavaScript to run when you click on my name. And all that stuff is munged together in one HTML page. And so we definitely need to worry about that with cross-site scripting, and we'll talk about Sql injection as well. So a cross-site scripting attack is really attacking the user in their own web browser. If an attacker can get some code to run inside the user's browser, it can do what the user can do in their browser. So if the user is able to view their online banking, the attacker's JavaScript can view their online banking. If the user can transfer funds, then the attacker can transfer funds. So, it's kind of a bit of a bummer if you're writing online banking and attackers can do this in your app. So as I was saying, HTML makes this hard for us by mixing multiple concepts into one giant blob of text. And if the attacker can alter the DOM, then they can do anything the user can do. So you can find XSS using automated tools relatively successfully, at least all the low-hanging cross-site scripting. Okay, so I'll do a little demo of cross-site scripting. Here's an app that I prepared earlier. So in this app, you can review products that you've bought. Damn it, someone's been here before me. I'll find something else. So this family-sized dome tent, I guess I could add a review like, my family is not sized for this dome tent. And then that'll be a helpful comment for other you guys have seen how reviews work. Okay, I don't have to explain how reviews work. Now, in this application, the application is taking what the user types in, storing it in the database, and then displaying it when the next user comes along. So if the attacker is able to type text in here that will run JavaScript, so that's just a a very simple script alert tag. Then the next person that comes along and views the page, JavaScript runs in their browser. I'm sorry about the screen res there, but you'll just have to trust me that there was an alert dialog that had the number 1 in it, which is international sign for an attacker was here. So what have we done wrong as a web developer? We haven't encoded the data correctly when we're displaying the contents. So here is the first comment I put. It's inside a, what does TD stand for? Table data. It's inside a cell of the table, and that looks fine. But in the second place where I've output the data, the script tag that the malicious user put in is being put straight into the HTML without any encoding to stop the script tag running. So there should be actually &LT semicolon for the less than sign and other HTML encoding so that the browser knows this is data to display as text, not script. Okay, pretty simple demo. Okay, so what do we do about cross-site scripting? Well, technically what we want to do is encode all the user-supplied data to render it safe. Unfortunately, that's not as easy as it sounds, because like I said, one blob of HTML can contain, it can contain HTML, and it can contain CSS, and even in HTML, it could be tags, or it can have attributes. And the way that you use the data means that you need to encode things differently. So if I'm putting the user's name inside a table cell, then I need to make sure that I encode HTML, encode it so that less than signs don't look like HTML tags. But if the username's in like a title tag and a href or something, then I need to attribute encode it. And if the user's first name is inside a JavaScript block, then I need to JavaScript encode it. And if it's inside a JavaScript block, inside an HTML block, then I don't know, I guess I need to do both of them. And it gets really hard really fast. So really the advice here these days is to use a templating framework that assembles your HTML for you properly. So rather than having to remember, okay, what are all the bad bits of data that might be in my application? How do I encode them this way or that way, depending on how I'm using them? You just say, like element.title equals, and the templating framework does it for you. And hopefully most of you who are building recently, building new apps, have chosen templating frameworks. And we've definitely seen the prevalence of XSS go down as people have been adopting more modern frameworks. The last protection against cross-site scripting is content security policy. And I've done a talk on this at a previous OWASP event. You can go look at it. I made like a pick-a-path book. It was one of my more fun talks to assemble. Yes, so content security policy lets you tell the browser which JavaScript is safe to run, essentially, is the summary of that. And then, obviously, the browser knows not to run the other data. The other data is JavaScript. Okay, the second one is Sql Injection. This is pretty fun. So it's very similar to cross-site scripting in that we're mixing the user's content and code, but it's not running in the browser, it's running on our database server. And the code might be something like a select statement, and the user's data might be able to change that select statement to do other stuff. I haven't been keeping track of my time, but Ramandeep will let me know. So here's an example select statement that's selecting customers from an accounts table based on their ID. And the problem is, what if that ID contains something like drop table accounts? Now the select statement is going to finish when it gets to the single quote, and then it's going to run a second statement which is going to drop the table. And most of the time when that happens, the developer's going to have a bad day. So this is the same reason. SQL statements combine both code and data. So here's a demo. Sql Injection is quite a fun one to demo, so I might spend a little bit of time on it. I'm hoping you'll be able to see me typing. Sorry, it's very high resolution. I'm not used to. So this has a search box. So if I search for Barbados, it'll show me the products that have the word Barbados in it. If I search for E, it hopefully shows me everything. And you can kind of think in your head how this is probably working. Is in the back end, there's probably a select star from products where title contains an E, or I don't know, description contains an E. That's pretty close to how I wrote it, I think. Okay, so the international hacker keyword for Sql Injection is a single quote. And if you have an application that does that when you type a single quote into it, you know that there's a cross-site scripting error, or you're dealing with a government department. And Mr. O'Flaherty can't put his name in. So you'll notice that the error message didn't tell me it was a Sql Injection issue or expose any information. So I've kind of done one thing right in this application. I haven't exposed the full exception stack trace. But the bad thing that I've done, apparently, is my application's in development mode. And it's in production, so whoops. So what are we going to do? So the first thing that an attacker wants to do is figure out how many columns are in the product table that's being displayed. So the single quote will end the select star from blah, where the description equals. So we'll just do that. Okay, so putting a single quote, stop that statement, and then dash dash means any other gibberish that's on the end of the SQL statement as a comment. So let's do union select. Now we need to try and select data from another table, but first we need to know how many columns, because it has to be in the same shape that the application's expecting. So we're going to try and figure out how many columns the response has. So it doesn't have one column. So I'm just copy and paste each time I try. You might notice that this is a very manual process, and there's a handy tool called Sql Map that just automates this for you, and it's remarkably fast. But just for demonstration purposes, 3, 4, 5, I'm pretty sure it's 5 columns. Okay, so now there's the products, and where's the one I'm entering? Let's just search for something that's not there. Okay, so what that's done is it's searched for any product that has ASD, 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 union with a select statement that returns 5 columns, one with the values 1, 2, 3, 4, and 5. So now I know which is the 2 text columns. 5 is obviously the price, and if I hover on here, cracky, that's tiny, the ID column is number 1. And so now I know the shape of the data. It needs to have 5 columns. And now I can try selecting from tables and see which tables exist. So a table that could be useful is ASP.NET users. Did I write it down? Users, yeah, I think it's got an S. So now we want to find out what tables exist. And Sql Map actually uses a binary search to try all table names. But I think I've got that name right. Rats. I just need to get rid of all the regular products so it's easy to see. Okay, so I got the table name right. So now the select statement works. Have I got 5 minutes left? Yeah, cool. Okay, I'll wrap up after this. And now I can start selecting columns from that ASP.NET user table. So that would be a bad thing to be able to do. So here's one I prepared earlier. There's a column called password hash and a column called username. Normally you wouldn't want an attacker to be able to see those. But because the application has a SQL injection vulnerability, I can select out the admin username and the password hash. If any of you are like crackers, maybe you can reverse that hash and figure out the password. Or I could just tell you it's admin. So hopefully it sort of showed you how that works. And really it was the same issue that my search query is just being concatenated into code. And if my query can escape out of the code and run more code, then bad things can happen. I should try doing a drop table ASP.NET users. I wonder what will happen. Let's not do that at the moment. So yeah, we talked about this. The real way to prevent this is to separate code from data. So you have the part of your SQL statement that is code, and then you have parameters that are the data. And you'll use, depends on your language, question marks or @ signs in the code part to say, I'm going to provide these parameters, and then you provide them separately. Other extra layers of defense that you could do is validate what can be entered. So this is where the government department reference comes in. Often they'll only let certain characters in people's names. Hopefully that's not to prevent Sql injection. Hopefully it's just because their mainframe doesn't know Unicode. And as a last resort, you could try encoding characters, but the problem with that is you need to know everything that's potentially dangerous. So is a single quote dangerous? Okay, I can encode that. But what if it's a single quote from another character set from a different language? Is that dangerous? And you know, so you're doing a negative security model there. You're trying to find bad things rather than say what's good. So yeah, parameterizing is the main way to approach that. Now I think I have, how many more minutes? 2 more minutes. So I'll wrap up after A4, insecure design. So insecure design is not really a technical issue. It's more like a before you started building your application issue. And that's why there's an arrow pointing at a gender-neutral stick figure. Because it's the developer or the architect or the company that built the application that didn't think through the risks of their proposed design. So unfortunately, you can't just fix design flaws with code. So say your application by design asks people for their credit card numbers and then displays it back to them. Without changing the requirements of the application, you can't fix the issue that credit card numbers are exposed. So what we tend to do to try and prevent these issues is try to think about our designs in advance before we start building, or as we're building. We'll do things like threat modeling, we'll use secure patterns, and we may try and use reference architectures that sort of allow us to follow someone else's well-trodden path. Okay, so I'm going to pause here. So as I said, luckily we've got 2 time slots for this talk. So yeah, if you'd like to hear more, please tune back in at 10:55, which is in 6 minutes. And if you'd like to hear less, feel free to swap to the other stream. Cool, thank you very much. Tēnā koutou katoa. Welcome back, everyone, to the OWASP Top 6. So if you were here in the earlier session, we've already covered some of this stuff. Thank you for hanging around. If you're new, you missed all the good stuff. Okay, so we're continuing our journey through the top 10, and we're up to security misconfiguration, and I think this one probably makes sense without me even having to explain. You've misconfigured your system in a way that causes a security issue. So it could be security aren't configured properly, or you've enabled features that aren't needed, so your surface is wider than it needs to be. You haven't removed default accounts. Maybe your error messages exposing sensitive information. Just a general catch-all for you've kind of messed up in the way that you've set up your web server or your web application. So what can we do about it? Well, one of the ways that we can make sure that we start from a good state is to have a build process that's repeatable and that starts from kind of a hardened base image. So that might be your hardened version of Linux, which has all the services turned off that you use as the base for your VM, or it might be your container template, however it is. And then the other part of this is having a repeatable process so that each time you build, you don't have to redo any manual steps, and you know that your system has all the hardening in place. Disable all unused services, and also use platform tools to try and review your settings. This squeak is so funny. Sorry, I was talking about a squeak. If you're in AWS, there's a bunch of like Trusted Advisor and third-party tools that will give you clues at stuff that aren't at things that aren't misconfigured, that aren't configured properly. So use those tools. Okay, vulnerable and outdated components. This one also probably just makes sense, right? Unfortunately, our applications use tons of components. So there's the operating system, there's the web server or the database server or other application servers. There's the libraries that we use from the main language vendors and the third-party libraries. Some are open source, some are closed source, and they'll end up scattered throughout the user's browser on our web server. And there is a community of people that helpfully look for security flaws in these tools, and the vendors of the tools will hopefully provide updated versions that fix those vulnerabilities. But it's hard for us to keep track of that. And attackers can relatively easily enumerate all the libraries we use using the hacker tool of viewing source in the browser. So we have to expect that if we don't update our components, that an attacker would know. So the current mechanism du jour for this is having a software bill of materials, or figuring out all the components that are part of your software and having some like automated way of checking the versions of all your components. So have an inventory of every library that your application uses, what version it is, and whether there's vulnerabilities. Now there's vendors that will help you with this, and open source tools. I believe there's even some downstairs at the moment to help you build up an inventory and keep track of what's vulnerable. But also, like, reduction in the number of dependencies helps. So if you don't need to use a library, then that's one less thing you have to worry about. And your company hopefully has a patch management process, almost certainly up to the desktop and the operating system. Try and incorporate patch management into your application as well. And then the hardest thing for us to kind of encourage our organizations to do is actually to budget for ongoing maintenance. So upgrading jQuery is really hard. Upgrading React, upgrading the libraries often causes breaking changes, and you need to retest your application. And a lot of the projects that we work on are project-based. So when the project finishes, we walk away from it and there's no more budget to fix stuff in that project. And we need to change our mindsets to think about the whole life cycle of our projects, right from conception all the way, I guess, to decommissioning, and think that we actually need to allocate budget along the whole way for a couple of times a year upgrading our JavaScript libraries and retesting. I don't think there's a silver bullet for that, and it's really about just having those frank discussions with our management. Okay, identification and authentication failures. So if you've been following the OWASP top 10, the names for this category of issues have changed over time, but really it's about failing to prove that the person who is connecting to your application is who they say they are. So authentication, essentially. So the types of issues we see are weak session management, so having predictable session IDs, or simplistic cookies to mark who the current user is when they return to your site. But also other things related to your login process. So some common attacks are to try and brute force your login page. So you guess the username of a user of the application, and then you try a dictionary of common passwords. Or you start with 10 common passwords and you try every username and spray those passwords across every account. Maybe the forgot password flow is weak. So if you forget your password, maybe it emails you a link, but the link might be guessable by an attacker. So even though they don't receive it and they don't have access to your inbox to click on that link, maybe they can guess what it is. Applications without multi-factor authentication, it's getting harder and harder to not use multi-factor authentication in your applications and justify it. And actually sessions don't expire as weak session management. So identity and authentication failures demo. Should have just written demo. So this application is built on ASP.NET MVC. I can't remember which version. It's running on Linux. It should be pretty solid. But I sprinkled over some insecurity because I'm an insecure kind of person. Again, apologies for the zoomage. I'll see if I can zoom this part. I can. Okay, so I've just used the hacker tool of right-click inspector, and you'll see that you can inspect the cookies. If I had a cookie, I would offer a cookie to anyone can see a cookie problem with my cookie. I don't have a cookie, but can anyone see it? Okay, well, I'll tell you, my ASP.NET core identity.application cookie has a value of test@testing.com. So my application is using cryptographically secure random authentication cookie. It's just putting the username into the cookie. So if I change that to an admin email address, the next time the user visits the site, now they're logged in as the administrator and they can see the admin menu. So that's a pretty contrived example, but I've done a little bit of pen testing and I've seen issues like this. So having a session ID that's an integer, having a predictable cookie, like you generate 100 of them and then notice that there's a pattern. So yeah, that demo feels a little bit flat. Well, anyway, don't do that. Okay, so what can we do? Well, it's very similar to the earlier advice, which is don't invent it yourself. So modern frameworks that we use for developing our applications typically come with authentication libraries built in. If you're a C# ASP.NET developer, every time they release a new version, there's a new authentication approach. It's really hard to keep up. But use the platform provided authentication libraries. Multi-factor authentication is a great backstop for other authentication issues because you're no longer relying just on passwords and usernames to protect your users. There's obviously a downside in terms of usability and sometimes cost, but it really takes you from 50% to 100% just by applying one sprinkle. Make sure your users are using strong passwords, and then think about how you'll detect brute force and stuffing attacks. So you may detect a brute force attack by, say, keeping track of how many times one user's password has been entered incorrectly, and then when they reach a threshold, perhaps lock the account or get them to back off for a certain amount of time. Password spraying is a little bit harder because they're trying lots of usernames for a given password. And so then maybe you would implement some kind of rate limiting based on the IP address of the attacker, and see this IP is trying lots of passwords, or maybe use some kind of log analysis to try and detect when multiple IPs are being used, or to detect kind of suspicious activity that you then promote to using a captcha to try and stop scripted attacks. Just pause for a sec. Cool, so software and data integrity failures. So this is a different category to the using outdated components, but it's kind of related. It's the software that you're using in your application. Is it the software you think you're using? So you've probably seen talks or online articles about people going into application stores and registering apps with the same name as a legitimate application, or going on to NuGet and registering packages with the same name as Microsoft's package name, or using the NPM repo and putting fake packages on there to try and trick people into installing the wrong version of the package. So there's definitely an issue there, and it's quite hard for us to tell when we look at a package in production, is that the one we thought we were supposed to be putting into our production environment? So some of the things that we do by mistake, we might download from untrustworthy sources. We might not be integrity checking. Sorry, each time I look to the right, I remember I need to speak slower. Sorry. Not integrity checking the packages. So often they'll be published a checksum, or the package will be signed by the manufacturer, the company producing it, and we can check those signatures before we use the package. A common issue at the moment is attackers getting access to the developer's computer or the CI pipeline, and being able to substitute their own packages, either into source control or as part of the build process. And like this category also covers data integrity issues. So do we trust the data that attackers are sending to our application, or users are sending to our application, and then deserialize it into memory? Or are we carefully validating the data and make sure we can't be attacked in that way? How many minutes do I have remaining? 15. Okay, so I'll do a demo of deserialization attacks, even though I didn't have it in there because it talks a bit longer. My application has two APIs. One lets you search for products and returns a JSON blob so you can embed product lists into your own website so that you can be an affiliate. And then the other API lets you query shipment status, and you might be a shipment partner or something like that. Okay, so it's contrived, but whatever. And I've made kind of one of those like API helper user interfaces that's really useful for developers. So if you enter a search term like board, it'll build the JSON request, and then it'll send it to the API, and you can see the response. And so I searched for board, turned into that snippet of JSON, and got the response, which is the stand-up paddleboard we saw earlier on the screen. What the application is doing behind the scenes is it's taking the JSON that goes over the network and turning it into objects in memory. And it does this by deserializing. So here's one I prepared earlier. So I'm using a library called JSON.NET, which is actually a pretty rock-solid library developed in Wellington by James Newton King, and now shipped as part of ASP.NET. But it has this feature you can turn on, which is serializing and deserializing custom objects. And what will happen then is it embeds, you can see that, embeds the type of the object when it generates JSON, and then when you're turning it back into an object, it looks at the type and creates that type of object. And so what you can do in this example where I've enabled that feature, which you totally shouldn't do, is now I have to figure out what objects are in this application that I can instantiate and cause some malicious action. And so after a bit of fooling around, I found out that the file info object was loaded into memory in my application. It's a standard library for checking if files exist. And if I pass JSON with that type, it'll create a file info object, and then it'll return a different message based on whether the file exists or not. So if this works, I get an empty string. So does that mean web config exists or doesn't exist? Just run it again, and I get an error message. So now I can enumerate the files that are in the application. And obviously that you don't want your attacker like instantiating objects that run code. So this kind of deserialization attack is kind of severe. And what attackers do is they sort of build up these gadgets of commonly used objects that have side effects that they can attack your applications. Cool, so what can we do about this? Well, for code, like I said, digital signatures, using trustworthy repositories, perhaps having your own internal repository that's curated, rather than just saying, every time you use another third party, including their NPM or NuGet or RPM repository, as well as all the other ones you do, actually clone the packages into your own repository and have a process where you curate those. And so you could use products that are sold to do that. Supply chain dependency checks. So there's other tools that will do this. There's OWASP open source projects that will help you check your components, and there's commercial tools. And then when it comes to dealing with data and worrying about attackers manipulating the data, pull things out of your grab bag, like encrypting the data, checking for it being tampered, making sure that you don't trust everything that you receive. Cool, okay, security logging and monitoring failures. We're on the downhill slope of the top 10. So the biggest failure that we have is we don't log stuff, and we don't look at the logs even if we do log stuff. And so we want to make sure that when our application is reaching error conditions, that we're writing those errors somewhere, and that we have a gender neutral stick figure looking at that place that they're being written to. And this allows us to detect incidents. It allows us to understand what happened, what the attacker did, as well as the attack. Like maybe we can see what other stuff they've done. And it also allows us to attribute, or at least attempt to attribute, the actions to who did them. Your mileage may vary. I think pretty much you just say it's Russia these days, and that's attribution. So yeah, we need to implement logging. I mean, I don't really have much to say apart from we need to implement logging. That is the advice. But I guess something that I could have put on the slide was try and think about the abuse cases for your system. So if you have a chance to do some threat modeling, think about the kinds of things that attackers might do, the kinds of the boundaries of your application where untrustworthy systems, people are interacting with more trustworthy systems, and how you could log at those points to try and get those key log messages that you can then detect later. Cool, and the last one. This is a new entrant in the top 10, and you can listen to Brian's talk that I linked, and also these slides will be available to click on that link to find out how they introduced this. So server-side request forgery is a really kind of interesting attack that seems to be increasing as we use more cloud infrastructure, which is one of those funny things where somehow we're getting less secure by using the cloud. It's not really, it's just that there's a new category of attack that works well. So in a server-side request forgery attack, an attacker is tricking your web server into calling out from the web server to some other system on the server side. And it might be tricking the web server to access other web servers in your data center, to access the database, using your web server to attack third parties, or even just looking for open ports or IP addresses in your internal network to gather more information about your environment. The reason that I pointed out cloud is that the way the cloud environments work is they encourage you not to put credentials into a virtual machine or your Docker container images, and instead to receive their credentials from the cloud metadata service, which is sitting in the network and will hand your virtual machine it needs when it boots, which is like it gets rid of that problem of having passwords scattered all over your network. And as your container boots or your VM boots, it'll ask the metadata service for credentials that give it its role access to things that it can do in the cloud environment. And the way they work is they have a well-known IP that's listening. Your container makes a web request to that and gets back its credentials, which means that if you can trick a web application into accessing this IP, you can potentially get that web application's credentials, and that would be bad. So let's do a demo of this one. There's actually a whole talk on SSRF. I've got the link, I think it's tomorrow, so maybe it's later today. So come along if this interests you. It's quite a fun attack. So the interesting thing about this is when I built this vulnerable application a couple of years ago, I didn't actually intentionally include an SSRF vulnerability in it. But being the good developer I am, it just turns out there's one there. Actually what I included was XML attacks. So this XML API has an entity expansion attack, which means I can essentially exhaust the memory of the web server. And it also has external entities enabled, which means that I can send a request that will request the contents of files on my web server. And the XML parser is expanding that as it's trying to process the XML. So if you're interested in those, I don't think there's a talk on XML attacks this year, but go and look at previous talks or Google them. It's a pretty fun attack category. And it turns out that my library lets me put URLs in, and when it expands this file, it's looking in the entities to see what ampersand file means, and then it's going to that URL to try and figure it out. And will that work? We'll find out. Okay, so I got an error message for that, but here's a URL I prepared earlier. And so this is that. This is running in AWS, and please don't hack me. This is the magic URL for the AWS metadata service, which is 169 dot all those numbers. So I'm actually just having trouble copying and pasting. How embarrassing. So, every AWS environment has this IP address listening. It gives different credentials to whoever connects to it based on which VM they are. And if I connect to it, in my XML parser, it's returning the IP address because the endpoint that I'm accessing is the what is my IP address endpoint, which is, like, oh, whatever. I mean, I guess that's a internal IP address, so it's a bit of information leakage. But there's another endpoint that returns credentials, and these are the real credentials for my my ECS container. So please don't type them in. But in my defense, it's an isolated account just for this demo, so I don't know what you'd be able to do. And so that's going to the /identity credentials, EC2, blah, blah, blah. And what it's returning is security access keys, tokens, expiration dates, basically anything you need to do to connect to AWS APIs as if you were that container running in ECS. That's kind of a big deal because whatever my container can do, now the attacker can do. And there's a few defenses that AWS has tried to add to protect against this, which I encourage you to read up on. And there's a few problems, which one of them I wanted to mention was often people give their VMs or containers or services elevated privilege, especially during development. Maybe you just give it like wildcard access to S3 because it's too hard to figure out the bucket name. And then if the attacker manages to get your credentials for your application, it can do stuff to the rest of the AWS environment that you weren't expecting. So something to watch out for. So that's a really fun attack. So in a traditional environment, you would try and segment your network so that the blast radius is lower if any one component gets compromised. You obviously shouldn't trust input data. If your application requires users to enter URLs, which you then go and fetch, like maybe you download an image for them, this is a kind of attack that you're going to have to threat model and try hard to figure out how to defend against. And it's not easy to determine if a URL is a safe one that has an image at the end of it, or if it's an internal URL, or if it's an attacker-controlled domain name that then redirects to an internal URL. So yeah, that's just my caveat. Like, read up on this, go to the later talk. Don't respond to the client with the raw details, obviously, and following redirects. Oh yeah, so Nick's talk is today. It's at 3:30 in track 2. And I imagine Nick will be taking a bit deeper dive than my 5 minutes. Okay, so we've come to the end of the OWASP Top 10. I'm hoping that there's no questions because I haven't left time for any. I will be... There is one question, okay.
Someone wants to know if you would be sharing the links to your presentation?
Yes, so all the talks for the conference will be published. We'll get PDFs of the slides, and we'll also have the video stream, and my PDFs have the links clickable in them, so hopefully that'll work. Also, I'll be hanging around. I don't really like mingling that much, but yeah, approach me, and if you want to ask any questions, and I'll try and be brave. So next steps, attend OWASP events, check. Search for the OWASP Top 10 category names with your framework in the search query to try and find out how your framework defends against them. Watch YouTube videos, sign up to Pluralsight. Troy Hunt has some great training videos. When you discuss bugs with your colleagues, try and use the official terms for them from OWASP and build that common vocabulary. And try and keep track of what issues are affecting your organization, and then use that to build up your defenses appropriately. And then the last point is go beyond the top 10. So like I said at the beginning, these are the first things that an attacker will try, the first things that you'll try and defend against, but unfortunately the list goes on, and you'll find out more over the course of this conference. Yeah, enjoy the journey. I don't know about you, but some of these attacks were really fun. And, try and get enthusiastic and share your enthusiasm with other people so that they can join the journey with you. Cool, that's all. Thank you very much.